Hello everyone, today we will be taking a look at my brand new, homemade ESR meter. This thing is used to determine the equivalent series resistance of capacitors, which is important because a higher than normal equivalent series resistance can result in some bad things. And look, it even comes with a little certificate of calibration. So I know this thing is perfectly calibrated in all ways possible. Anyway, let's get that thing out of here. So, this thing, to turn it on, you just plug it into a 12-volt power supply. The needle shoots up to the over range mode. And let me go ahead and prop this thing up using a nickel metal hydride battery charger. And now, if you tap the leads together, it goes down all the way to 0 because that is 0 resistance. So, anyway, let's go ahead and get a capacitor. This is 4.7 microfarad, 50 volts. And this pin on the left is positive, and this one on the right is negative. I can tell this because I have connected the negative directly to ground, and the positive is connected to the output of this little oscillator circuit, which is the reason this thing can work in the first place. But anyway, negative to negative on the electrolytic capacitor, and of course positive to positive. The ESR is very low, about 1 ohm, as you can see. Now, let's try a capacitor with the same value, still 4.7 micro, 50 volts. Let's connect up this one. This one doesn't move nearly as much. It only goes to just below 5 ohms, probably around 4. And as I wiggle it around, it just keeps getting crazier and crazier. This capacitor probably has an intermittent connection in it, and that is significantly altering the ESR as I bend the pins. And this is bad because a high ESR in an electrolytic capacitor can cause the voltage across that capacitor to start changing way faster than it should. If this was the smoothing capacitor for example, the chip in a switching power supply, and it got high ESR, then the chip won't receive a steady voltage, and it could mess up the switching power supply. And that is why capacitors with low ESR are typically almost always used in switching power applications. However, the thing is, this thing can only measure the ESR of small resistors because, or I guess small capacitors, because bigger capacitors always have lower ESRs. So, for example, in my giant bin of capacitors, let's get a 1000 microfarad 25 volt capacitor with pin extensions added for good measure. So let's hook this thing up. Of course, negative to negative and positive to positive. And as you can see, this thing actually shows 1 ohm, which is kind of interesting, but the calibration on here is a bit messed up, so the 0 point is already pretty much at 1 ohm. So this thing is basically shows as a complete short circuit, and I would have no idea if this thing is bad or not, because high value capacitors, even when they're bad, still tend to have a low ESR. And this is still an issue. Like, for example, if this capacitor was on the output side of a high current switching power supply, it could, a low ESR could mean, of course, voltage fluctuations at the output, which isn't good, but it could also result in over voltages on the primary side and blow up the switching transistor or transistors, and end up causing a cascading failure, sometimes causing multiple components to fail. And speaking about the calibration of this thing, as you can see, it is already significantly off. The way you can calibrate this, directly mechanically with the meters that you can actually pop the cover off, and this little wing thing can be adjusted to properly set the calibration. And now it does properly show 0 ohms, but it gets stuck at 5 ohms because of reasons, mainly because the scale has actually detached from the surface. Let's see if I can get this to proper working order. Well, this thing is absolutely terrible despite its little certificate of calibration. So this thing can't really work for large capacitors which have low ESRs, even when their ESRs are still high enough to be problematic. And the funny thing is that this, of course, isn't the original scale for the multimeter. This is the original scale. It was a DC microamp meter, and the funny thing is that, if you can tell, there is some glue residue on it, and this is because this thing originally had another scale over it, because this little meter right here used to be the meter of a product called the jeweler's eye, which was an instrument used to determine the genuinity, or whether or not certain gemstones were genuine, by measuring the refractive index of the gemstones. And it was just a little paper sticker that had some different ranges for different types of gemstones. But that thing was has long since broken. Its battery had corroded. I have repurposed its case for my little taser thing, which is also broken. So now I'm using the meter for this little thing. The way this thing works is that it has a little 555 timer which generates a high-frequency signal, which is about 120 kilohertz in my case. It sends it out to the capacitor, and then the voltage drop of that signal is measured when the capacitor is connected up. A higher voltage drop means a lower resistance and closer to a short circuit, and it is measured by the meter, of course, which measures the current, and some resistors adjust the voltage threshold and the sensitivity and stuff. And there are some capacitors in series to filter out any stray DC, because this thing is basically just an input turning on and off, and we want a pure AC signal from this. In fact, let's see if I can measure the exact frequency on in the oscilloscope. So here I have the oscilloscope set up. And let's connect the ground on the oscilloscope probe to a suitable ground on the board, and let's measure the direct output of the oscillator. So we got a signal. Let's go ahead and trigger it, and maybe adjust the trigger level and center it. So we got an approximate square wave at 120 something kilohertz. So there's a little capacitor over here to filter out the DC. So now we have this signal over here, which is intermittent because I don't really have it set correctly. And there you go, that's your signal. Let me see if I can adjust it. There you go. Yeah, there you go, that's your signal after the capacitor. And yeah. Anyway, let's see if I can search up some of the other things, like, for example, what exactly is on this point right here. That is the little signal, and this is also pretty much the exact same signal. There is very little voltage difference between these 2 points, which are, of course, the pins on the meter, and this is because this thing only measures extremely tiny voltage drops, because it is a 50 microamp meter. Anyway, that is about it for my extremely terrible homemade ESR meter.